Hello everyone, I am Priya, Department of CSE from Hindustan College of Engineering and Technology. Today I am going to handle the topic of deadlock from operating systems. So in this topic I am going to discuss about the system model, deadlock characterization, what are the methods to handle the deadlock and how to prevent the deadlock, then avoid the deadlock. So first one is system model. So here we are having set of resources and set of processes. So that process will need to execute in CPU. So for that it will send or it will use three kinds of things here: request, use and release. Deadlock characterization. So here these are all the characterization of deadlock: mutual exclusion, hold and wait, no preemption and circular wait. So mutual exclusion meaning is at a time only one thread can execute, that is mutual exclusion. Then hold and wait, the thread which is holding some process and holding some resources and requesting the another resources, that is called as hold and wait. The no preemption, till the end of execution the process won't release the resource, this is called as no preemption. At last one is circular wait. We have set of process or set of threads starting from T0 to Tn. T0 is holding some resources which is requested by T1, and T1 is holding something which is requested by T2, and this will be in continued. So circularly one thread is waiting for the resources which is held by another one. Then resource allocation graph. So this is a resource allocation graph. We have set of resources and set of threads. Each and every resource has set of instances within that. The dots are indicating the instances type. So R1 only one instance, R3 one instance, and R2 two instances, R4 having 3 instances of resource type. So here in the graph, resource allocation graph, we can say that if cycles exist then there is a deadlock there. If cycles not exist then there is no chance of deadlock here. Then methods for handling the deadlock, we have to use deadlock prevention and deadlock avoidance. So prevention in the sense, before occurring the deadlock we will take some precaution steps and avoid the deadlock. So that is preventing the deadlock. Deadlock avoidance means it has happened, so we have to avoid the deadlock. So prevention, we need to concentrate on mutual exclusion. We can use the read-only files, non-shareable resources here. So hold and wait, we have to check whether the thread is having some resource. So after the release of particular resource only, we have to allocate the another resource to the thread. Then if the system is in safe state, then there is no deadlock there. If the system is in unsafe state, then we can say that there is a deadlock there. So this is a diagrammatic explanation of unsafe and safe state of deadlock. Then avoidance of deadlock. So we can use the multiple instances of resources. So based on that we can avoid the deadlock here. So for both the type we can use some kind of algorithms here. So multiple instances we can use the Banker's algorithm. Here we have to use 4 data structures here: available, max, allocation and need. So available indicates the number of available resources in the certain circumstance. Then max, what is the maximum number of resources available. Then allocation, what is the number of allocated resources to the threads. Then need, after the allocation of the particular resource type, so what is the additional need. This is the safety algorithm notations. So here we have to check what is the work available, then what is the finished state of the particular thread. Banker's algorithm. So in the Banker's algorithm we are using the threads. So here we are using 3 data structures: allocation, max and available. So for each and every time notation we have to check the thread requirement, based on that allocate. So this is the example for the Banker's algorithm. Thank you.